Yes. My event is starting. Oh, wait, maybe I shouldn't be showing this yet. That's fine. It could be back here, right? Hello. I think I've started streaming. Welcome to the Coding Train, live on a Friday. So this is a special Friday Coding Train episode. I have a very special guest, and this is my special guest's project that this about approximately 1 hour live stream will be about. Audio is low. This is good. So I have a 2-mic setup going, and so let me debug that a little bit here before I get started. I'm opening up the Slack channel, which is for patrons. So make it louder. So hold on, special guest. I don't know why I'm making this like some sort of like surprise reveal, but special guest. Just say like a couple sentences and let's test your audio.
Hello, testing. Can you do a cut to me while I'm testing audio?
I can actually.
Hello.
Oh, we're wrong. Cut to special guest.
Oh, hello, testing.
All right. So is it just my mic that's low? I can hear him, but I can't see him. No, that's for you will in a second. Is my mic lower than my special guest's mic? Because you don't know who it is. It's going to take a minute. The one issue with live streaming is the chat is about 20 seconds behind us in real time. Mm-hmm. So that question, they won't actually hear it for about 20 seconds.
I love it. It's
my
awesome.
mic is fine. Hi, mine is low. Shiftman mic is low only.
Is my mic low? Is my mic testing?
No, yours was fine. And I can actually turn. So first of all, I'm kind of okay with my mic being low. First of all, is it actually registering my mic? If I'm tapping on here, are you hearing like a tapping? Both mics are fine. I'm going to up mine.
I'm tapping mine now. I have to tap on mine.
Because it could be I'm low just because they're only hearing it through your mic.
That'd be interesting.
No, it's mine's here. I turned mine up a little bit. Okay. I hear tapping on both. I can hear you both fine. Okay. Hello. Welcome. I have a very special guest here in the Coding Train studio. I'm going to cut to a special guest. Welcome to Jabril. If you're not familiar with Jabril's YouTube channel, I probably just Google Jabrils on YouTube. It's also, I learned how to say it now. SEFD stuff.
You're wrong. No, I'm joking.
SEFD stuff, SEFD stuff on YouTube. Jabril has been teaching himself machine learning for the last around 9 months. And has discovered and made all sorts of exciting and interesting projects, has made a bunch of videos about those projects. I happen to be in New York this week. He's actually doing a short-term residency at ITP, which is a program where I teach, and has taught a workshop here this week and gave a presentation about his work. So it's Friday afternoon, Coding Train time. And so I thought I would bring him here to talk about a new project that he's making. So before I get to that, let me just do some housekeeping. Today is going to be a shorter live stream than usual. There won't be any coding challenges or tutorials from me. I hope to make that up with a bonus live stream next week or the week after. But happy whatever holidays that are happening today and this weekend that you might be celebrating. I have to catch a train in a couple hours. So look, it's funny how I have to catch an actual real life train in a couple hours to head out of town. So this is just going to be a guest session. I will say though that if you don't subscribe, I don't know why I'm like pretending I don't have a computer here. YouTube. Let's search for SEFD stuff. So this is. Hey, you have 2 YouTube channels.
I have a million channels. To be honest,
I kind of knew that, but I forgot about that. Do you work on all of them still?
No.
So this is the one you're actively maintaining still.
Jabrils. Yep.
Just this one. Okay. So this is Jabril's YouTube channel, and you can see. Just memorize this channel ID. I'll read it to you. Capital U, capital C. Getting this down, capital Q.
Whoa, you're cheating on your numbers book today.
Oh yeah, we're going to have you read some random numbers. What was I saying? So you should definitely subscribe. You should click, look, I'm going to subscribe. So the reason why I'm not subscribed is not because I'm not subscribed. It's because this is a fake account that I set up that I bought YouTube Red with, so that if I look at stuff on YouTube on my live streams, the ads don't show up. It's also a YouTube channel, an account that my kids use when they watch YouTube, because I don't want them to have to watch the ads either, so you can see what kind of videos they like to watch. And look, Jabrils visits the coding train. Okay, now let me go back, and I'm going to give you a clue here. What you're going to want to do is you're going to go to his channel. You're going to want to click subscribe. Then you're going to click this alarm bell. I learned about this today. I actually already knew about this, but the alarm bell's going to, if you could do this with my channel too if you want. I guess you're probably already subscribed if you're watching.
Do it.
But it'll give you it will give you a notification as soon as there's a new video. And the reason why you might want to do this is Jabril will be publishing a new video on Sunday that I think you're going to want to watch. That's all I'm going to say about it. Okay, so if you want to get that notification, it's going to be on his channel, so you're going to have to subscribe. There. Okay, I'm looking at the chat. So I think that, look at this. These are some great, let's look at these. Look at your friends. Okay, so also, by the way, this I learned about recently too. Jabril is doing live streams. I guess I could let you talk about your own stuff. I don't know why I'm doing it. I can't stop talking. This is my channel. I guess I'm in charge here. This channel is where Jabril does his live stream archives get published here.
Correct.
But your live streams are actually on Twitch.
Correct, yes.
Okay. And then also the Physics Girl is an awesome channel. Coding Train is it's kind of okay. And I don't know some of these other channels, but I'm definitely going to have to check them out. They look cool. All right, so, and here you can see YouTube, Jabril, real life, Jabril, YouTube, Jabril, real life, Jabril. Okay, if you're reading this,
you've been hacked.
You've been okay. All right, he's like a real life YouTuber in person. I don't think of myself as that because I'm like an old person, but he's like
what does that
full
mean?
of, I don't know, youthful energy. Okay, I have. All right, so I think, let me mention two other things. Number one is there's a lot of live streams going on right now. I saw that, normally I would tell you to watch something else if it's just me, but since it's Jabril, you should stay here. But there's the Glitch channel. This is totally giving me the wrong stuff. Glitch, code editor, YouTube. I don't know why, I saw that they were live streaming. I can't find it. Never mind, Glitch. Glitch, I don't know why I'm plugging Glitch, but I love Glitch. It's a code editor, not an official sponsor or anything, but they have a live stream going on today. And then there's also the TensorFlow Dev Summit. This in particular I wanted to mention. Let's see if we can tune into the live stream really briefly. What are we learning about now? All right. See, now you don't hear the audio from this except through my mic. So maybe I should just do a voiceover. Saying these workers, servers, and there's very little going on. Same. To estimate, I can't do it. Never mind. The TensorFlow Dev Summit is going on live right now. I don't know what this is about. But, and I think earlier already today, there was a very exciting announcement. If I go to js.tensorflow.org, I think? Yes. So you might have heard me talk about a project called DeepLearn.js on this channel. What happens if I go to deeplearnjs.org? It's still there, but it now says exactly what I wanted to tell you, is that deeplearn.js has become tensorflow.js. So that's pretty exciting. It graduated, it grew up, it graduated. It's a teenager now, maybe, in whatever computing years, open source years. I don't know how that translates to dog years. But a member asked in the chat, can we get to the point? Very unlikely that's going to happen anytime soon. I do not get to the point. It's really exciting that how this project is growing to be able to unlock and make possible more types of machine learning algorithms and possibilities in the browser. And I have been working on a project at ITP with a bunch of researchers. I know Jabril has been experimenting with it for maybe an upcoming project. If I go to github.com/ML5JS, and I'm going to go here. So this is a machine learning library, kind of like a higher level, simple, basic library to do some machine learning stuff that is built on top of deeplearn.js, wherever that went away. And now that deeplearn.js has become TensorFlow.js, this means we're going to do a lot more work on this to support all the new possibilities that are unlocked from TensorFlow.js. In particular, most of our examples in this library involve using pre-trained models. And if you want to train your own model, you've got to go and set up your Python environment. We have some tutorials for that. But now we're going to start to be able to make some examples and things where you can actually do the training in the browser. So I'm slowly getting to it, but this is, I hope, going to be a big focus of my channel April, May, June, however long I have the energy to do this over the summer. So that's coming. Let me see if there are any questions in the chat. Is it efficient to learn in the web? I don't have an answer to that question. It definitely does not. It's what the researchers at Google have done in making TensorFlow.js is nothing short of heroic in getting all of the matrix operations that need to happen in WebGL using the GPU of the computer in the browser. But its performance is still not going to be as fast as kind of native C++ TensorFlow, but it's remarkable how fast it is, and the ease of not having to set up an environment and just go to a web page to execute a task, to program something, to make an animation. I think there's a lot of exciting possibilities there. Okay. So let's transition now to our guest. And so let me see. So I don't remember, I'm trying to remember. Oops, you can step into the frame. Welcome, Jabril. So I'm looking over here because I have a monitor over here. So one thing, by the way, is that I have to practice is that the people we are speaking to are there. But you'll notice I do this a lot, like blah, 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 because I'm staring at the monitor.
I was just observing you. You're very pro.
Okay, so I'm trying to think when I first discovered Jabril's channel, and I wish I had a good memory of this or story of this, but I definitely remember when I first saw his video on the Run Forest project. So I'll let Jabril introduce himself and say more about his background and how he got into this machine learning stuff, if you like, rather than try to do it myself. But what I loved about that, I have a book that some of you might be familiar with called Nature of Code, where I have a kind of a chapter on neural networks and a chapter on genetic algorithms, and they're kind of old and out of date. And I've kind of been wanting to expand that and do more with it. This is my camera that goes off every 30 minutes. Now you know you're experiencing this live. And so when I saw that project, the Run Forest project, which if you haven't seen, it's a Unity-based simulation that trains a simulation of Forrest Gump, basically, character to run around a maze using both neural networks and genetic algorithms. And it was really like, I looked at it like, oh, this is the perfect kind of demonstration example in the kind of creative coding or game making or art making context of how to apply machine learning to a simple, I mean, it's not that simple, but to a graphics motion-based simulation. So I was super excited to see that. Inspired me to think about some new stuff and where I wanted to take some of my tutorials in JavaScript. I don't know. The internet puts people in touch. I've been watching his videos. I think he's watching some of them, sometimes mine. We'll see. And so, so welcome to the coding train. So what I'm going to do awkwardly is I'm going to take my coffee and my laptop, and I'm going to slide out of the way and go sit. There's a chair over there, and then I'm going to turn it over to you. I might mute my microphone, and you can talk about your project and code, and I'll watch the chat to see if there are questions. So after like a little bit of time, I'll come back and I'll ask you some of the questions that people have asked.
Sweet.
Make sense?
Very cool.
Okay. Shuffle, awkward, shuffle, awkward. Okay.
All right. Howdy, everyone. How is it going? So yeah, I'm going to give a little brief overview about who I am for those of you that do not know, which I'm sure is all of you. So my name is Jabril. I run a little YouTube channel called Jabrils here on YouTube. And recently I converted my channel to focus on computer science. That happened in September. And that was probably one of the best things I've ever done because I learned that, I had a great passion for writing code and making products and projects that were based on computer science. And so, obviously if I had a passion for that, it was easy to show that in video projects as well. And fast forward, so one of the biggest projects that I produced to date is the Run Forest project that got a lot of eyes. I'm really grateful for. And that really harnessed the power of machine learning, which is a really big buzzword these days. And yeah, that's pretty much overview. I spent 9 months learning on how to write neural networks from scratch,
I'm going to pause here for a second. People are telling me the audio is low.
Oh, okay.
So let's do a little. I'm sorry to interrupt you in the middle.
No worries. Is my placing good?
Oh, you know what? It's because it's going through. It's fine. You're good.
Okay.
I have an idea. Let me just check a couple things.
Okay. I gotta fill time, so I'll dance.
I actually muted myself. Okay. Tap your mic for a second.
Okay.
It's this one. Let me just turn it up. So let's see if this is better for people.
All right. Just let us know if this mic is still too low. But yeah, that's pretty much the overview. I spent about 9 months learning how to write machine learning algorithms from scratch because it was something, AI is really cool to me, I think. And so yeah, the Run Forest was released. And today, what we're going to do is we're going to examine this really simple JavaScript machine learning application, kind of how it was done. It's another machine learning application wrote from scratch. So we're going to take a look at the code and all that good stuff. So let's get into this. So here we have this example. It's what I call a Color Predictor neural network demo. And it asks you a simple question. Does white or black look better over this color? And so the color is within the circle and it's randomly generated. So we use can I use the whiteboard?
Yeah.
Okay.
So what you have to do is press 2.
2. That's it.
Oh,
okay.
I have to turn this camera back
Okay.
on. And then.
Sweet.
And then you come over here.
And I just walk? That's it?
And if I'm sitting here, am I in the shot?
No. Okay, so what's important for us to start before we can get into the application, we have to understand the main computational part of this application. So we have a color, and as you know, colors they're represented as a vector of 3, or sometimes 4 if you include the alpha, but we're not including the alpha, we're only going to use the RGB values. So we have our inputs, which is 3. Is that all in the frame? Yes. All right. So we have red, green, and blue. And these are values between 0 and 255 for each input. So we need to build a neural network that will be able to take these inputs and then do a computation on them and then pass them to an output to predict if it looks better over black or white. So let's first draw our outputs. Just make sure it's all in frame. Yes, that's good. And this is going to be, it predicts black, and this predicts white. So now we need a hidden layer, is what we call hidden layer, with artificial neural networks in the middle that does the computation part. And this is our guess. And so we are just going to arbitrarily just duplicate the same size of our inputs for our hidden layer nodes. We're just going to say 3. It's a good place to start. If we're really serious about this, we could expand it, try 5, try 7, and just log the results for all of them and see which one works the best. But we're just going to say 3 for this example, make it nice and simple. And so we have our RGB, and if we go back to
Press 1,
our example, what's happening here is there's a computation that happens within our network. 2, 3, 1, 2, 3, 1, 2, 3. And Dan, feel free to interrupt if you think that I'm a little off base with anything. Okay, so what did I just do? That looks really confusing, but it's actually really simple. So we need to somehow get our inputs, computation, and into our outputs. And the way that we do that is we use what I'm using bubbles to represent what are called weights within our neural network. And so every single node within our hidden layer has the same amount of weights as there are inputs. So what that means is there's one weight for this input, there's one weight for this input, and there's one weight for this input. And the same for the rest of them. One weight for this input, one weight for this input, one weight for that input, and repeat. I didn't do that right. Boom, boom. And so what then happens is that we pass this through, we do our input times the weight, and then plus our bias, and we can repeat the process. This will give us a value. Let's say that after we compute all these, sum them up, add a bias, it will give us, let's just say 0.5. And then we'll pass that to our outputs, which is 3. Boom. Pass it to our output, and then that will give us a value for each of these. So let's say this is 0.3, and then this is 0.7. And then it's just as simple as we'll just say that this is higher, 0.7, so it's guessing white. So that's a quick overview on what's going on here. Daniel's going to post a more in-depth tutorial on this, or you already have, or?
Well, so I have tutorials on neural network stuff like this that people could go back to. This is the same kind of structure that I've used in my neural network library videos. And I was thinking at some point, maybe next week, hopefully, I might try to recreate your project as like a coding challenge. Okay. In which case I'll revisit this.
So we can put a link to your
yes.
Okay, so we'll put a link to Daniel Schiffman's series in which he goes in depth with this. So if you want to learn more about what's going on here. But that's a quick overview on the math, on the computation. So our inputs, it gets times by weight and biases, then we get a value, and then we pass that to our output, same computation, and then gives us a prediction. So.
Oh, and actually there's a bunch of questions.
Oh.
I might as well ask,
yes.
Can I interrupt you and ask questions?
Yeah, let's do it.
All right. So people are asking, are you using libraries? Let me just give you a bunch of questions just because the chat's going to scroll too fast.
Okay.
Or actually, no, it's fine. I've stopped it from scrolling. So for question number one, are you using any libraries or are you building this from scratch?
Okay. So yeah, so this is a from scratch computation. We're doing this completely from scratch. And it's not necessarily important that you do from scratch neural networks, but if you want to get a good understanding on how to debug networks, this is a really good way to go about ensuring that you can do that. Yeah.
Okay. Next question is does the input have to be from 0 to 255?
Okay.
Shouldn't inputs have to be normalized? What's from 0 to 1?
Yes, great question, great question. So again, I just glossed over this, but so normalizing inputs for colors is actually really simple, and it is always best to normalize your input data. So because we know that the domain for a color value is always going to be 1 to 256, or in computer language, we shift that by 1, 0 to 255. We can simply just divide whatever this value is over 255, and that will remap this between 0 and 1. And so essentially, when you're writing your program, you would just pass the input through a function that would just divide it by 255. So. Yes, great question.
All right, one more question. So I'm kind of curious about this too. I sort of think it's probably, I'm like answering the question before I ask it. But is there a benefit to having 2 output nodes rather than just have one, since there's only that's arranged between -1 and 1 or something like that?
Yeah, so there's a lot of debate on this, and I agree with the side that it's easier when you have classifiers versus if you have just one output node that is mapped between -1 and 1. Right, and then if it's above 0, then it's going to be white. If it's below 0, then it's going to be black. Yeah, based on the research that I've read, it's always best to go on a classifier.
Yeah, and it seems to me like maybe this would be fine in the case of there's only 2 labels or 2 classes, but once you have more than 2, it's going to be problematic. And so as a demonstration and learning, even though this might be a very basic scenario, it's useful to demonstrate the multiple outputs because you're going to need to do that if you were to expand this further.
Correct, and the whole reason for that is because what happens when you separate them is you get probabilities versus you get a map of between 0 and 1, which again, if it's one output, you can get away with that, but if you try and encode your outputs using this for 30 different, the neural network might not make good sense of that.
Cool, all right.
Cool, so let's continue on. because we need to get into the code part. So let's look at some of the code as to how we went about writing that part of our neural network. Right, down is up. I keep forgetting. I'm new to Mac, so please forgive me here. All right, so, and you beautified my code.
Sorry.
No worries, no worries. Beautified and zoomed. Okay, so we first need to define all of our variables at the top. So RGB is our input. And then we have the amount of choices, which is a variable that we use for our output. Just give me 1 second to skim this, make sure I don't give you the wrong information here. Sweet, so we set up our variables. RGB is our input data. And then so one thing that's really important that I should go over just to make sense of what's going on here is, wrong computer on this one. Delete that. So it's really important. In order for you to write your algorithm, you need to know how to compute both of these. So this is really just an array of values. So we can call this array G of I, right? So this is G of 0, and this is G of 1. And G just stands for guess. I put 0, G of 1, right? And so we want to know, what does G of I, or what does G of 0, or what does G of 1 equal? How can we get that equation? Well, if we look at our diagram for our neural network, it's actually quite simple. So this is in frame right here. So we can do G. Oh my goodness, can I write?
You actually have a lot of room to like this way too.
Yeah. Okay, so let's do it over here. So G of I, which again is this array, this output layer, G of I equals the summation of hidden layer. This is going to be hidden layer of I, and this is going to be inputs of I. That's how we define each of these vectors. So G of I equals a summation of HL, hidden layer, and then we have to go into another loop because we can't use the same indice of I and J because it won't return the right value. So hidden layer of J, which is just going to be 0, 1, 2, times the weight of G of I. Right? And then we simply just add our bias of G of I. And so this is the equation that we can use to compute each of our output nodes. And so just to clarify what's going on here, this is summation symbol, which simply means to add up all within the array. So hidden layer of J times the weight. This is a function, which simply just grabs the weight of whatever output node you're on. So if you pass G of 0, for example, through this weight function, it will just grab whatever whatever weight of G of I is there. So that's actually G of I of J, actually. G of I of J. So now we have this equation that tells us exactly what these values equal. So now we don't know what HL of J equals, so we also have to define HL of J. And we go about doing that by doing the same exact process. Actually, this would be HL of I for indices. Same exact process, summation of our inputs, right? Inputs, what I use, IMP. Inputs, J times weight of HL of I. So the same exact input. We need HL of I. And then we simply just pass our bias. And again, this right here is a function. All it does is it grabs the bias for whatever node that we pass through it. So bias of HL of I. And there we have it. We have our entire equation because we know exactly what input of j equals. It's going to be simply the random value of our color. And so this is what we need to write in our software. How are we on time, Dan?
We're good.
Cool. I keep forgetting up is down. That's interesting. Okay, so same exact thing that you see on the board is what we write here in our code. So first, before we can get what the guess nodes equal, we have to first get what the hidden layer nodes equal. So simply put, as we did on the whiteboard, hidden layer 0 equals, we'll get to what ReLU is in a second, but hidden layer 0 equals, we did our input encoder, which was a question that was asked earlier about normalizing our input data. So this function simply just divides our input divided by 255, and then we'll times that by the weight of our hidden layer. So this is an array function that I will go over really quickly, that we instantiate to hold all of our weights. So color predictor 0, 0, 0. I'll go over this. I think it's important. So the function color, can you see this? I think so. Color.
You're close to the top of the range.
Okay. And there's a lot of data that you have to remember. This is interesting. Color predictor variable. So there's all these different dimensions to it. And I think it's interesting, or it's important to go over what the dimensions mean. So let's just get 2, and then let's just do, I don't know, 1. So what does this mean? If you have color predictor I0 to 1, what does that mean? Well, so we want to store these arrays into our color predictor variable, and we go about doing that by defining the location of all of these. So the hidden layer is going to be 0, and then the guess is going to be 1, right? And so all the nodes are then going to have their own assignment. So 0, 1, and then 2. Same here. This is going to be 0 and 1. And then the weights are also going to have their own assignment as well. So 0, 1, 2, 3, and the same deal. 0, 1, 2, 3. And we repeat that for every single weight inside of the nodes, right? And so how this works is our color predictor is, if we want to grab a reference to 0, that is going to be hidden layer. And then 2 is going to be the last node, and then 1 is going to be the second weight, because it starts 0, 1, second weight. So this variable is grabbing a reference to this weight. That's exactly what color predictor 0 to 1 is doing. And so you see this I, that's an extra dimension that you might be confused about. So let's talk about that real briefly. So, a lot of information. There's a lot of information, but bear with me here.
Just switch your camera.
Oh, switch camera. Okay, all right, I knew that. All right. So you see this extra I, and what does that mean? So traditionally, with such an example, you would use backpropagation to train this neural network. However, time was a factor, and as well as we wanted to go over a lesson of both neural networks and genetic algorithms. So why not combine them together is what we did for this example. So the I is actually just grabbing a reference to what predictor we are currently using. So genetic algorithms real quick, you have to have a population, you have to assign fitness scores to every single, what's the word I'm looking for, the creature within the population, and then you have to mutate them and breed them in X, Y, and Z. So we have a population of 100 predictors at start, and then they all have randomly initialized weights and biases, which again, just to make sure it's clear, are all of these values. Weight, bias, weight, bias. These are all randomly initialized. The function that we use for this program is randomized between 0 and 1. And then they all, based on their randomly initialized weights, will make a guess on which one they think is correct. And so most of them said that black is the correct color that looks best over this randomized color. And then we simply just use a genetic algorithm to train this predictor to converge on the best possible predictor. And yeah, that's a general overview on this. The code is available on GitHub, and I left a lot of comments. However, it will require a bit more in depth if you really want to like get a full grasp on this from knowing absolutely nothing. If you already know some stuff about neural networks and machine learning, I'm pretty sure this example is pretty straightforward from you. But the benefit of writing neural networks from scratch is that you really have a good grasp on what's going on behind the scenes versus using libraries, and you're able to debug different problems that might arise when you are writing your neural networks, be it from scratch or using libraries. Yeah, and that is pretty much it. We do have plans to update it with the actual backpropagation algorithm in there so that you can learn from that as well. And yeah.
Yeah, all right, let me turn my mic back on.
Okay.
I think
Where did that cap go?
Oh, the cap. I picked it up, I held it in my hand, I put it in my pocket.
It's very cool.
So let me come over here. There are a few more questions.
Okay.
Let's see what I can find here. First, people had asked, is the code already at GitHub, or on GitHub, or are you gonna update it on GitHub?
Yeah, I still have to upload it to GitHub. Yeah.
So stay tuned. Whenever it's on GitHub, I will come back and edit the description for this live stream and put a link to.
But they can currently go to sefstuff.com/color.
The link that I use.
Right.
Yeah. So you can go to. Let me zoom in here and show you. So sefstuff.com. This one. Right? Yes. So if you want to grab the code right now, and I don't know why, whenever I paste links into the YouTube chat, they don't seem to work for people.
Interesting.
So, but anyway, so I would paste this into the chat, but that wouldn't even work. So you can see it up there, that you can grab the code now. But I will also include a link to GitHub repository, whatever that's. And it is my intention. I think one of the reasons why I love this demo, and people were kind of asking this a bit in the chat, was like, do you really need a neural network for this?
Right.
And I think to me, that's a perfectly valid and interesting question, and probably the answer is no, you don't need a neural network for this. But when learning about neural networks, when trying to build your own machine learning project, if you can start with a well-defined, small in scope problem, then you can really figure out, and because in some ways I do this similarly with some of my genetic algorithm projects. I take an example where I know the answer. Right. So I can see if the genetic algorithm worked. Because ultimately what I want to do is use a neural network or a genetic algorithm in some domain where maybe I don't know the answer or couldn't solve the answer easily, but to figure out how those things work, I've got to come up with it. And so this is a really nice problem for that, because it's simple, small in scope, and for people who want to do creative coding and graphics and design stuff, it's got color and then graphics.
And not to mention, once you learn how to do this stuff from scratch, this is easily scalable for the most part. You still have to worry about some other stuff like vanishing gradients and stuff like that, but for the most part, you can take this and scale this up and it'll work just about the same. So there's also that benefit as well.
So there were a couple questions that came in on Twitter. Ask Jabril hashtag. There were a lot of questions like, how are you speaking with your mouth? There was a lot of moving. There's a lot of that.
I am a bot.
How can I become like you? I don't know if that's an answerable question, but that was a question that came in from iDiaxiso on Twitter. So here's a question from I am Roshan on Twitter. This is a big question.
Okay, let's do it.
I don't know if, and I think this is a question that I've certainly touched on. And but how is AI? Let me read the question. How it actually is written. How is AI different from a neural network or deep learning or machine learning? They often seem to be used interchangeably and cause confusion. So first of all, I want to say, like, This is a really good question.
Yeah.
And I struggle with this question all the time because there's all these different terms. So let me list those terms. Artificial intelligence, deep learning, machine learning. And then I might put neural network in a different category. But that's another term as well. I don't know if you have a kind of way that you describe the terminology to people when they ask this kind of question.
Yeah, I like to start with English is difficult. I like to start there. But for the most part, AI it's like a grab all for everything AI. Like you can hard code AI. You don't have to use machine learning. So that's kind of like the grab all for it all. And then what was the code words?
So, oh boy, all these things are coming in. AI, machine learning, deep learning, neural network.
Yeah, and so machine learning I think is like the next level down. So you don't need to use a neural network to do machine learning. There are different ways that you can go about teaching a machine how to learn. One really good example is decision trees. People have developed really complex decision trees, and the machine just kind of explores the space and learns the best way to use this decision tree. So that's another way of applying machine learning. And then, what did you say, neural network and deep learning?
Yes.
Yeah, so neural networks is essentially what we showed. And even that's kind of up to debate because recurrent neural networks are neural networks, but they're not really, neural networked, if that makes sense. So I don't know. If you say neural network, people know what you're talking about for the most part.
All right, I'm going to try to give my take on this. Let's see if I can do it.
Let's do it.
I forgot already what I was going to say. Well, I think I would put neural network in a different category than those other terms. Because to me, neural network...
I need to look at the camera.
I know. I don't know.
I'm so bad.
I don't have a good... I wanted to get a Between the Ferns set up in here, where I could get a camera and some chairs, a little coffee table, and could have a conversation. But instead, it's just the awkward standing thing. Somebody in the chat told me to put a mirror behind the camera.
Oh.
And then we're talking to each other, but looking at the mirror.
I like that.
That might be weird, though, if there's nobody else here.
I'm kind of egotistical. I'll just...
I used to have a screen over there, and I would always stare at that. But anyway, so the reason, neural network to me is a particular algorithm that involves connected nodes and data flows from one node to the other. And there could be different architectures and styles, and so that neural network data structure algorithm can be applied in the fields of artificial intelligence, machine learning, and deep learning. But neural network is an example of a particular algorithm, I would say. You could sort of think of it also as a data structure, but there's an algorithm there in terms of how the data flows through the structure. So that's what I think. And then I think that to me, artificial intelligence is this umbrella term that is really just hey, can computers and can technology have intelligence like humans do, and what does that mean? And apparently my technology is not intelligent enough to record a video for more than 30 minutes at a time. So I think of that as a very broad umbrella term to just the big field of simulated intelligence. Whether is it real intelligence? Is it the illusion of intelligence? Is that the same thing? It's kind of a deep philosophical question. And then machine learning to me is a subfield of artificial intelligence involving making sense of data. So you have data, and that's input to a system, and you have some output, which might be making sense of that data, whether it's a prediction for something that's going to happen in the future or a classification of something. And then I think of deep learning as a kind of almost like a modern rebranding of machine learning with neural networks. It's hey, we have bigger data sets now and faster computers now. All of a sudden, those things that people researched many years ago called neural networks that nobody thought could really do anything, or they thought could but couldn't, now all of a sudden we can do more of them with. And so it's really just it's not meant to be marketing, but it's kind of marketing this idea of big data, neural networks, and together.
Yeah, I agree. I think it's a lot of the marketing side of things because you'll read so many different posts what's the difference between deep learning and machine learning?
Yeah.
It has 2 hidden layers. That's it? Yeah. Literally. I think it's more the marketing side, my personal opinion, but that's awesome.
Cool. All right, let me see if we have any other. Oh yeah, neural network. I like this definition. Neural network is a universal function approximator. This is actually this is relevant. Let's try this. Oh, this is crazy talk now. Now I'm coming over here. I actually think this is really kind of a good way to think about it. I was thinking about this the other day, because what if we made function Color Predictor. And we just had like an if statement in there, and you give it a color. So if the brightness, blah, 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 of that color is greater than some value, then you should put black on that color or white on that color otherwise. So this is like a hard-coded function that takes inputs and returns an output.
Right.
And so we could write a lot of if statements. We could get really crazy complicated about this. We could come up with a whole set of rules. And a neural network, in a way, is a thing that you could put in here to kind of learn to return the value according to, in a more mysterious way, in a sense. It can learn, it acts, so in a way, like, do neural networks and machine learning replace coding?
Right.
I don't think of them as replace, maybe someday they will in some weird way, but I think of it as like they don't replace coding, but they can replace or act as a function in your code. So that function that you might have hard-coded with a lot of if statements can now have a machine learning system in it, take some inputs and generate an output.
Yeah, I agree. I mean, when it's all said and done, algorithms are input, instructions, output.
Yeah.
And you're just replacing the instruction part. Yeah.
Totally. I believe Suraj already did a video on that. I think Suraj, having already done a video on that, is probably the answer for everything we might ever talk about in this. Because he definitely has a video on
That's
everything.
the new Simpsons did it.
Coding train, are you going to show us the working code or is it just a discussion? So I think we're wrapping up here. This was really just a discussion. The code is here. Some people had asked just to scroll to the top. Maybe I hadn't seen what was at the top. But I don't know if that really matters. But I'm standing in front of the code anyway. But this code is available at that URL. There'll be a link in this video's description. And I think, I don't want to I feel committed to doing this. I just don't know when exactly it'll happen. But hopefully sometime next week, I'd like to make my own version of this project, which I'll do like in a coding challenge from scratch. So then we can kind of compare and contrast that. And I have a feeling that you're probably going to have some other video content about this project at some point.
Yep.
Did I mention that you should subscribe?
There's going to be a special guest.
Did I mention that you should subscribe?
It's going to be a special guest. I don't know who. I have no idea who.
Wait, how do I? YouTube. Do you know you can get one of these vanity URL things now? So you can get like this.
I
don't know, because I have one now.
I need to look into
I don't know,
that.
maybe you have to be like very special on YouTube to get that unlocked for you. I think you're special.
Excuse me.
But I'm just going to search for you again.
If you just do Jabrils, it comes up.
Oh, well then you
top
have
one.
that. You have that.
I don't think URL though.
Oh,
You just have to search it and it comes
Oh,
first.
yeah, you have to search it. Yeah, I see.
Can't miss it.
Yes. Okay. So here, once again, subscribe. So I'm gonna just show you that I'm gonna unsubscribe. This is terrible. Unsubscribe. Now I'm gonna show you how you do this. You search Jabrils in the search bar. Then you click subscribe. Then you click the alarm bell, because if you want this special surprise video that might come out very soon, you'll get a notification. Okay. You need 100 subscribers to get the vanity URL. So
I got some work to do.
Yeah. All right. So let me just check to see if there's. Oh yes. People are asking your Twitch.
Oh,
so let's see if we can. If I do this, what do you think the chance that'll come up?
It's just Jabril CPU. Yeah, it's right
there it
there.
is.
Oh wow.
So if you go to twitch.tv Jabril CPU, that's Jabril's Twitch. And actually, so I was going to say this for you, but.
Whoa.
All right. They can't hear this, by the way.
Oh.
They can if it comes through our mics, but the audio from this laptop.
So they just seen us freaking out over
Yeah.
just something was.
But actually, I'm curious. So tell me about your, because I always feel like I have no idea if I'm doing. I don't think there is an answer to this. Like my process, I have this weird process. Like I do live streams that are on YouTube. Then I cut up and edit the live streams as separate videos, also on YouTube. And sometimes I think, I should be live streaming on Twitch. Should I not be posting redundant? Anyway, so how do you separate those? You have the YouTube channel, you have Twitch, and then you have a second YouTube channel.
Correct.
Jabril CPU.
Correct.
What are those pieces?
Yeah, so I'm keeping my focus on the Jabrils channel, like the main one.
Yeah.
So I'm literally live streaming, and then whatever comes out of that is being straight uploaded to YouTube.
But it's a separate YouTube channel. Like
Correct.
The live streams on Twitch don't show up in the Jabril's.
Correct.
Jabril's YouTube channel. They show up in the Jabril's CPU YouTube.
Correct. Unless I do like really special live streams, then
Okay.
they go
Then
on.
they go there. Yeah.
Yep.
So you have 3 things to subscribe to: Twitch
wow.
live stream, YouTube
wow.
live stream archive, and the main channel.
Oh wow! Thank you. Thank you.
You at least subscribe to the main channel.
Definitely the main channel.
Yes, Bruno clarifies you don't need 100K subscribers, only 100, and then you can do the channel name thing. So you could get youtube.com/Jabrils or How come I can't say that? Sef stuff. All right. So let me see. Let me just check the Ask Jabril hashtag on Twitter. Maybe that's the thing. See if there's anything. No. Okay. Anything else? There actually somebody used this earlier in 2012. There's some weird.
Oh, interesting.
So I should have made this Ask. Let's see, Jabrils with the S. Let's see if that shows up. Yeah. So next time, you're not seeing this, but next time. We'll do a different hashtag. Anyway,
very cool.
So what time is it? It is 4 o'clock. That means I have to leave and go catch my coding train. So I will be back for sure next Friday. I hope that we'll be able to do more collaborations like this. Jabril is based in San Diego, right? So we do not, even though San Diego sounds dreamy to me, so I'm definitely gonna have to go on a trip there sometime. But Wake Me asks, when is the next coding challenge? So I'll probably do coding challenges again next Friday. If I can get it together, I'd like to try to at least tackle this color predictor idea before next Friday. Oh, let me show one thing.
Okay.
You can, I don't know where you want it, you can stand here, because I wanted to mention people, most recently I did a coding challenge about quad trees. No, okay. So github.com/coding-train/quad tree. And so if you remember the code demo, this was what I did in my tutorial. So I just made a whole bunch of random points in space, 2D space. Then I registered them in this quad tree data structure, which you'd have to go back and watch the videos to find out what that is. And then I had an algorithm that, in a hopefully faster way than iterating over all the points, pulls out a selection of points within a certain radius. And actually, I didn't do the circular region in the tutorials. Somebody sent a pull request in after I uploaded the code for the circular region. So then what I did, and I want to do this as a coding challenge, but I did it in class, my NYU class earlier this week. I did a collision detection test. So let's look at this. So this is just a simple example that has, I believe there are it's down here. There are 1,000 particles. You have such a nice smile on your face. There are 1,000 particles, and I'm testing if they are intersecting. And when they're intersecting, they're highlighted white. When they're not intersecting, they're just gray. And you can see I'm getting a pretty reasonable frame rate. I bet you I'm getting kind of a lower, I was getting 60 frames per second, no problem, when I tried this. So maybe it's just this computer, or because it's hooked up to the streaming system, or there's other things in the browser, like the Twitch channel going. But anyway, the point is, I'm going to uncheck this using quad tree. So as soon as I uncheck this using quad tree, it's going to, for every dot, iterate over all the dots instead of using the quad tree. And you can see now I'm at 4 or 5 frames per second. So we can see how the quad tree, at least, even though I did get a lot of comments along the lines of, you're doing your quad tree incorrectly. There's ways of making it better and more efficient. And 2 is like, why are you doing a quad tree in JavaScript? That's sort of silly, like it's not going to be very fast. And so while all of those points are valid and true, I would say, you can see that even with all of my failings as a programmer and using JavaScript, I'm still getting like an incredible speed performance. And like if I go down to like, I can see even with like 3,000 particles, I'm still getting like 15 frames per second. And if I uncheck this, I mean, just forget about it. I don't even, oops, it couldn't even, oh, you can't see what just happened. It like checked itself. No, it's okay. So you can see like the frame rate is officially 0 right now. So if I can manage to check that again, we'll see. So there is certainly, I'm sure, like more optimizations that I could do, but there is a benefit. So I have a challenge for everybody watching. If anybody, right now everything is in this GitHub repo, codingtrain/quadtree, and you can see links to the video tutorials, the pseudocode Wikipedia page, and then these are the 2 examples. You're fine, you're fine. There's some other quad tree libraries in JavaScript that are down here. But I have a challenge for anyone, which is that I would love to have another example here that is flocking with quad tree. So I will be accepting pull requests if you want to make a flocking demo with this quad tree code. And I mean, I'll make this myself at some point, but I love to have people contribute. So that's one thing to see, like, can I get a flocking simulation in JavaScript with like 600 agents that's going to run reasonably well. Okay, whoops, I'm getting a notification here. Oh, thank you, 6E. 6E in the chat says, don't forget, you have to do this before you leave. This means we're wrapping up now.
Oh.
You have to read some random numbers.
Okay, all right.
Unfortunately, I don't have the soundboard with any lullaby music. You can pick a page, read whatever you like. Take your time, enjoy. I'll check the chat for any last important questions. You know what? This is silly to have the quad trees thing behind you. So let's. So I guess what probably makes options are your own website or just like the full. Let's just give you the full code.
Do I get the soundtrack?
I don't have it hooked up right now.
Dang it.
I can.
Dang it.
We can edit and overlay it later.
Okay.
That's why people can now. The other thing I could do is, this is fun sometimes. People want to make their own.
Oh, nice. Okay.
remixes of this. And then they can overlay music and whatever. There we go. I'll just step out.
7950.331 1.714 1.889 dash 0.858 dash 0.401 1.215 1.526 0.692 dash 0.567 0.410.
Beautiful. That was beautiful. It brought tears to my eyes. Like, people are telling me that it's very dangerous to stand in front of a green screen on the internet. But I do that all the time, and nobody ever. I made a whole I danced in front of the green screen for like 45 minutes straight. Nobody ever did anything with it. So, okay, there was some applause. All right, so quad tree neon. So I think we can wrap up. Thank you so much, Jabrils, for being here at ITP this whole week.
Thank you for
Thank you for coming and being a guest on the coding train.
Thank you for having me.
And to many more future collaborations and things like
Yes.
that in the future. Awesome.
You got to freeze frame that.
Yes. I was just glad I didn't mess that up
Yeah.
and do it miss or hit my face by accident or something, because that's typically what I would do. All right, so we're going to say goodbye. Thank you, Internet, for watching. Now go, if Glitch project is still live streaming or TensorFlow Dev Summit is still live streaming, or I don't know, go watch somebody play some beautiful music or something non-coding related. Turn off YouTube. Go outside. Be with friends and family. So anyway, you choose what to do. Don't listen to me. We're gonna leave. I don't have a good system for this. I just have to. Only thing I can do is I use this mouse and I go over here and I click this stop streaming button, and then we disappear.
Nice.
So I need a little outro video or something someday. I do have an intro video, right? I can actually just go straight to the intro video.
Oh, nice.
It's fun. But I don't have an outro one. Okay. Here we go. Goodbye.
Cookie.